Hello, 7-1. As you may be able to see and hear, I'm not there today because my voice is not working correctly today. So all I can really do is record this video and say, hi, I miss y'all. First, you will not be getting your quizzes back today because they're in my backpack and I am not there today. However, every single student in the class scored an A. There is not a single student who scored below an A. So congratulations, this is your Oprah moment. You get an A, you get an A, you get an A. Everyone got an A. So you will get your quiz back the next time I'm there. All right. For today, we're going to be exploring specifically solving equations with the form that have parentheses. And we're going to think about the two different ways to solve these equations. The first thing I would like you to do today is everyone take a marker out of your box and solve this equation on your desk. If you did not get out the marker boxes, please pause the video and get them out now. And then write down this equation and solve it on your desk. You can solve it any way you like. You can use a tape diagram, a hanger diagram, reasoning backwards or inverse operations, whatever way you like. But solve it on your desk now. Please pause the video so everyone can take a moment to solve this equation. Awesome. Now you're going to see some different student methods who tried to solve this problem, and you're going to compare it to your own. Let's scroll down and see. Here is the first method. This is Noah's work. Please pause the video now and raise your hand and share if you agree with Noah's method. Did he get the same result as you? Did he make an error? If so, where was his error? Awesome. Let's go to the next video, or the next example. This is Elena's method. Take a moment now to pause the video and share. Do you agree with any of their methods? Did they get the correct answer? Did they make any mistakes? Here is the last method. This is Andre's method. Did he get the correct answer? What do you think? Did he make any mistakes? Do you agree with his method? Pause the video now and share. Awesome. There are two different ways to solve equations with parentheses like this. Let's look at it together. All right. I'm going to show it two ways. One way with a hanger diagram and one way algebraically. So if I were to draw a hanger diagram of this situation, I see three groups of x plus 2. That's probably too big. X, 2, x, 2, x, 2, and I have 21 on this side. Let's copy that over to the other side as well. One way to solve this equation is to see equal groups first. 21 split into 3 equal groups is 7. And then from there, I can remove the 2 from each side and see that x is 5. One way to think about this in an equation form is to first get rid of this 3 on the outside by dividing or splitting it up. Divide by 3 on both sides of my equation to keep it balanced. 3 divided by 3 is one group of x plus 2. But if I have one group of x plus 2, I don't need that one there. I can erase it. 21 divided by 3, we already know from our hanger diagram, was 7. Then I took away 2 from both sides. X equals 5. Because 2 minus 2 is 0. I don't need to write it. 7 minus 2 is 5. What's the other way I could solve this equation? I could rearrange my hanger diagram to put all of my unit values together and all of my x's together to help see it more clearly. I clearly have 3 x's and 3 2's. I can take off all of my 2's from each side to get 21 minus 6, which is 20, 19, 18, 17, 16, 15, 15. And then I can split my 15 between my 3 x's, which would be 5, 5, and 5. So again, x is 5, same answer. To do this algebraically, I can distribute my 3 to each piece. 3x plus 2 times 3, which is 6, equals 21. Then remove my 6 from each side. 3x plus 0, but I don't need to add 0, equals 21 minus 6, which is 15. And then I split my diagram up into 3 groups. So split into 3 groups. X equals 5. So my options are, I reversed these. So my options are inverse operations, undo the 3 first, or distribute first, where I multiply the 3 by each piece. So it's going to be your job now to practice choosing which one to do first. You're going to work on this classwork today. Your job is to decide whether you distribute first, so you multiply the outside number by each piece, or if you divide each side by that outside number first to see what happens. The instructions tell you to use both methods until you see a reason to stop. So if one method becomes too hard, you should stop and explain why. If you finish this classwork, I would like you to just begin your homework, not work on Delta Math. I hope you have a great day, and I will see you soon.